This is our arcade machine final presentation. I'm Tommy Ray.
I'm Sajana Bhakta.
And I'm Hunter Hovanek.
Originally, we decided to build a conventional style pinball machine. After construction had began, we realized that we would be unable to finish the project due to time constraints. As a result, we decided to abandon that project and create a simpler version, which is the topic of this presentation. The design cycle. The design cycle is a process used by engineers and entrepreneurs to design, construct, and test solutions to a problem. The steps of the design cycle go as follows. Define a problem. Identify what is needed to solve that problem. Brainstorm solutions. Construct and test a prototype. Evaluate results. Build a final product. And share results. In this assignment, we use the design cycle to complete the project. The problem. The first part of the design cycle is defining a problem. In our case, the problem was presented to us. We were tasked with the challenge of designing and building a mechanical arcade machine, which is both fun to play and involves the skill of the player. There were criteria which we were required to meet as well. That criteria includes 4 actions using a power source against a moving object, with at least one of the actions involving the skill of the player, and a mechanism to calculate game score. There were also constraints which we had to abide by. Those constraints include a 3-volt limit on electronics, easily sourced building materials, a 2-foot by 3-foot by 3-foot maximum size limit, and a $40 budget maximum. Brainstorming solutions. As a team, we got together to discuss how we would meet the criteria set forth by the project guidelines. We decided to make a 2-player game, since there's nothing more fun than simple one-on-one competition. We then had to decide how we would set the game up, and after some deliberation, we decided on a 2-player pinball machine. The machine would consist of 2 downward-facing slopes, with flippers on each side. The players would use the flippers to launch the ball over the center line and attempt to score on their opponent. Depending on their skill, the opponent could either shoot the ball back or miss it, allowing the other player to score. We had the general idea, and now we just had to come up with 4 actions which would affect the ball. Upon reading the rules, we found that the downward slope on either side of the game would count as 2 actions. We also knew that each flipper would count as 1 action, so together we already had 6. However, we expected the game to be somewhat boring like that, so we decided to include 2 electric motors with spinners, which would need to be avoided by the players. Construction. After the design was finalized, construction of the final product began. Due to the size and cost of materials, no prototype was created. This meant the final product would have to be modified and corrected as needed. The game housing and playing surface were created from 1/8 inch Luan plywood, and the flippers were constructed from 3/8 inch diameter wooden dowels. Tension springs were purchased from Lowe's, and 3-volt electric motors were sourced from the resource room. Meanwhile, the spinners were modeled in CAD software and were 3D printed at D.H. Hill. The total cost of construction materials was under $20. Construction took roughly a day, and design work and painting took roughly 2.
After construction had been completed, we were eager to play the game. Shortly into the first match, we realized there were some pretty obvious issues which would need to be addressed. The first issue we realized was that the flippers were not tall enough and the ball would easily bounce right over top of them. This made the game unplayable since half of the time the player was unable to play defense. This solution was easily fixed by simply gluing another 3/8 wooden dowel on top of the original, thereby doubling the height of the flipper. The other issue, which became apparent, involved the spinners. We discovered that the spinners were spinning fast enough to launch the ball clean out of the playing zone. This was a major issue since the ball would oftentimes land several feet away. We quickly came up with 2 solutions, either way, to keep the ball in the deck or slow the motors down. Slowing the motors down would have been easier to do, but we liked the challenge of a high-speed spinner. They made the game much more fun to play. As a result, we cut sheets of acrylic and glued them in place over the playing deck, thereby enclosing the ball in within the playing deck. The solution worked great as it prevented the ball from coming out of the playing zone. Overall challenges and after FEDD failures. Over the course of the assignment, we found it very hard to work on the project. We were not allowed to use the on-campus workshops without training, and the training schedule did not fit into our schedules. As a result, we had to work on the project with crude hand tools in our dorm rooms. We also experienced a mechanical failure of the flippers as a result of FEDD. The game was played almost constantly from beginning to end, and as a result of this use, The game began to fail. The bolts which the flippers pivoted on began to oblong the holes in the flippers, resulting in a loose and sloppy fit. This allowed the flippers to lift up off the playing deck when pushed by the player, letting the ball to roll underneath them.
Placement at FEDD. The machine earned an overall ranking of 5th place in the afternoon session of FEDD.
And here's a video of our game being played. Clearly, you can see a lack of skill from both players.
What would we do differently? If we were to complete the assignment again, we would make sure to have workshop training so that we could use the power tools on campus. Being able to use such equipment would have translated to straighter cuts and overall a much higher quality. We would also change the way which the flippers pivot, since that system has now been proven to wear easily and fail. Advice we would give to next year's freshmen participating in FED. Don't wait until the last minute. Attend safety training so that you can use on-campus workshops. Keep it simple. Complex designs take time to iron out all of the issues. And have fun. Don't stress about FED. The important thing is that you learn teamwork and the design process. Your final product does not have to be perfect.
And here are our references and sources.